Hi guys, I'm going through the answers to the Cambridge Diagnostic questions. Question 1, determine the values of m such that this vector has a magnitude of 5. Well, remember that the magnitude of a vector is the square root of the I value squared plus the j value squared. So that's going to be 5. Square both sides. 3 squared plus sorry about that little m there should go out there. 3 squared plus m squared equals 5 squared is 25. M squared is 25 minus 3 squared. It's 9, it's 16. So m is equal to plus or minus 4. Okay, make sure you've got the plus or minus there. 2 marks for that one. And let's keep going. Okay, for this question here, we require the circle theorem that's about two chords that intersect. So if I've got here, we've got chord AB. Chord's just a line that runs through a circle, and we've got chord DC, and they meet at a particular point. And on this, I'm going to call that point E. Now, the way that the circle theorem works is that I've got this length here times that one there is equal to that one there times that one there. So let's write that out. That is AE, which is this one here, AE times EB is equal to this one here times this one here, DE times EC. Now, this situation over here that we've got is the same circle theorem, but it just happens that our chords intersect outside of the circle, but we use exactly the same formula. So let's write in the numbers we know. AB is 8, BE is 4, and we know C, what do we have, D to E is 20, and C to E, this little bit here, is what we've got to work out. Let's call that X. Okay, so E to B. E to B, here we have E to B is 4. A to E, well, to get A to E, I'm going to have to add up all that distance. 4 plus 8 will be 12, is equal to D to E, that's the whole distance, times E to C, that's the bit we want, X. So all I'm doing is 12 fours are 48, divided by 20 is X, and that means that X is 2.4, and we're done. Okay, PRST is a parallelogram. M is a point on PR such that 2 lots of PM is equal to MR. So we've got this bit here. This bit here is twice as long as that bit there. And N is the midpoint of ST. So we've got that bit and that bit are the same. Now, PR is, we're going to call PRP. That means that all the way across here, that whole one is P. So this is, if this one here divides up into 2 pieces, 1, 2, and we've got another piece here, imagine it's 3 pieces all along, and P to M is going to be 1/3. So it's 1/3 of little vector P, and little vector P is going this way. And this one here is going to be 2/3 of P. Okay, what else are we told? R to S is R, so that's coming down this way, that is little vector R. Now, because we've got a parallelogram, these vectors over here are parallels. So to the top, well, this one is going to be half of P, and this one's going to be half of P. Okay, there we are. Express M to R in terms of P. M to R, that's this bit here. In terms of P, we've already done that. That's 2/3 of vector P. Next, show that M to N is R plus 1/6 of P. Well, M to N, let's find it. M to N, we've got to express that. So all I'm going to do is add up the vectors. So I'm going to come around that way. So what do we have? That's going to be 2/3 of P plus R, and then I'm coming backwards on this one. So that's going to be minus 1/2 of P. So that's going to be, would be nice if our vectors had common denominators here. So that's going to be 4/6 of P plus R minus 3/6 of P. well, what do we have next? We've got r, that's this one here. 4/6 minus 3/6, that's 1/6 of p. And we're done. Okay, looking at this next question, I can see we've got an isosceles triangle. Those ones the same. And we've got these base angles of 3x minus 4. So this one over here has to be 3x minus 4 as well. Now I can also see I've got an alternate segment theorem happening here. See that? So it's going to mean that this angle here is the same as this one here. So that's going to mean that this one just here is 44 degrees. That's that one up there. Well, what will this one here be? It's going to be 180 minus 44 and then a half of that. So if I work that out, 180 minus 44 divided by 2, that's going to give me 68 degrees. So now I've got 3x minus 4 is equal to 68, and I just solve that, add 4 to both sides, divide by 3, and I've got x is 24. Done. Okay, next one here. If n is a positive integer, then 2n minus 1 will be odd. Write down the next odd integer. Well, the next one, to get from one odd number to a next, what do? I add 2. For instance, to get from 3 to 5, one odd number to the next, I add 2. So I'm adding 2 here. That's going to be 2n plus 1. Minus 1 plus 2 is plus 1. Okay, prove that the difference in squares of consecutive odd numbers is divisible by 8. Okay. The difference means subtract. So I've got these two odd numbers, and they are 2n minus 1, then the next one is 2n plus 1. I want the difference in squares, so it's going to be 2n plus 1 all squared minus 2n minus 1 all squared, and I've got to show that that's divisible by 8. It's equal to 8k, where k is some natural number. Okay, well, let's look at the left-hand side here. I've got 2n plus 1 all squared minus 2n minus 1 all squared. Expand that out. 4n squared plus 4n plus 1 minus, keep our brackets here, 4n squared minus 4n plus 1. Okay, so what am I going to have left? Let's look at, I've got 4n squared minus 4n squared, so that's going to be no n squareds. What have I got next? I've got plus 4n minus negative 4n. 4n minus negative 4n, that's 4n plus 4n. That will give me 8n. And what have I got left? Plus 1 minus plus 1, that's 0. So it equals 8n, which is equal to 8k when n is equal to k, and k is a natural number. So we're all done. Proven. Okay, here we've got an inclined plane situation. And what is it that we need to find? We need to find what this angle here is. Okay, first thing I'm going to do is just spin my axes around such that that is my x-axis. So I'll just redraw the situation here. And I've got, if this is 30 degrees here, well then this one here, our force is going to be coming down, angle of 60 degrees there, and we're told that's a force of 8 kilogram weight. Okay, now we've got our angle coming up here at theta degrees, and we're told that that's 7 kilogram weight. Now what I'm going to do is just resolve both of these vectors into their horizontal and vertical components. So this number here then needs to equal this amount here, because it's the particle is in equilibrium, which means that it's not moving. So how do I work out this blue bit here? Well, it's going to be 8 cos of 60, and that must equal this yellow bit over here, which is 7 cos of theta. So how am I going to work this out? Well, cos of theta is going to equal 8 cos 60 over 7, and theta will equal inverse cos of 8 cos 60 over 7. And that's just a calculator problem there. And we get theta is equal to, what is it, 55.15 degrees. Done. Okay, next one. AB is a chord of a circle. Well, let's just draw a picture. So here's our chord AB. And P is a point on a circle such that, there we are, AP is 7 and PB is 4. There we are. And P is 1.5 centimetres from the centre. So here's the centre of the circle. Now, that there is 1.5. Well, I'm looking for the whole radius. Well, the whole radius is going to be that much there, or up here, that dotted line plus that much. I'm going to call that bit there radius. What's this bit here going to be? It's going to be radius minus 1.5. Can you see here that I've got an intersecting chords question? So what is it? We've got this distance here times this distance here. 7 times 4 is equal to, let's have a look at it, this distance here times this one here. So that's going to equal r plus 1.5, lots of r minus 1.5. And I've just got an equation to solve here. 28 equals, well, this is a difference of 2 squares, isn't it? R squared minus 1.5 squared. A plus b, a minus b, remember that rule? A plus b, lots of a minus b, expands to a squared minus b squared. Okay, so r squared here is going to equal 28 plus 1.5 all squared. And what does that get? So r squared equals 30.25, and r is going to be the square root of that, which is 5.5. Now, it's not going to be plus or minus 5.5 because having a negative radius length makes no sense for that one, so just the positive. Okay, we've got another resolving forces question here. We've got this mass is being held by this string here and by this one here. Now, because it's being held still, we know that the vertical components of those forces are going to add to be the same as that. And we know that the horizontal components of these forces, they need to cancel each other out, so it's not moving from left to right. Well, so horizontal component of the red force there, we're going to have F lots of cos 60. Remember that cos will give us this one here, and that's going to be equal to the blue one over here, which is 80 cos of 30. So F is just going to equal 80 cos of 30 over cos of 60. And we work that out. Force is 138.564 kilogram weight, or if you've done that using SERDs, absolute values, 80 root 3 kilogram weight. Now find the exact weight of the box in kilograms. Well, so what we were saying before, this one that goes down is got to equal to this component here of that one, that vertical component of that one, and this vertical component of that one. Well, this yellow one here, you see it has no horizontal component, so the whole thing is just that. Okay, so I'm going to say, what is it? It's going to be sine of 60, F sine 60, and we'll work out, we'll pop F in there soon, plus 80 sine 30 is equal to the mass. Now remember the F is, we worked that out before, 138.564 sine 60 plus 80 sine 30 will give us M. Pop that in our calculator, and M is equal to 160 kilograms. Okay, here we go. We've got 3 points for this one. And let's just kind of roughly do it. P is 0, 3. And Q is 2, 7. and then we've got R, which is 4, 11. There it is. Okay, now express PQ in terms of I and J. So P to Q is this vector here. Now, vector PQ is equal to OP, is equal to OQ minus OP. Now, what is OQ and OP? So OQ is the position vector. The vector goes from 0 to Q, which is just 2, 7. So for these position vectors, all you're doing is getting their point and writing it like a vector. And OP is this one here. So PQ is just that. 2 minus 3 is 2, 7 minus 3 is 4. So PQ, and it says in terms of I and J, so that's going to be 2I plus 4J. Express PQ in polar form. Well, just think about that. It's 2 across, 4 up. So we could do an inverse tan for opposite on adjacent, 4 over 2. And then we could find the magnitude, or we could put the whole thing into our calculator. So it will come to root 20, 63 degrees, or you could have that as 2 root 5, 60 degrees, or 4.47, 63 degrees, there we are. And if I don't specify which one of those I want, give it to me however you like. Express P to R in terms of I and J. P to R, it's going to be this one here. P to R is R minus P. P to R, R minus P, 4 minus 0, 11 minus 3. 4I plus 8J. Hence show that PQ and R are collinear. They are collinear because they are multiples of each other. They both have a point in common. Got point Q there in common, they've got point P in common. They're collinear because PQ, 2 lots of PQ, is equal to PR. There we go. Final question here, and what we've got is a relative velocity question. So let's just write out our formula. Velocity of A relative to Earth equals velocity of A relative to B plus velocity of B relative to Earth. Okay, in this situation here, we've got Daniel and we've got Earth, or we've got Daniel and we've got the riverbank and we've got the river. Now, firstly, it says determine the speed of Daniel relative to the riverbank. Well, speed, we'll work out speed soon. We're going to work out velocity of Daniel relative to the riverbank. The riverbank is Earth, isn't it? So we're after Daniel relative to Earth. That equals Daniel relative to the river, to the water in the river, plus the river relative to Earth. Well, Daniel relative to the river, that's about how fast he can actually swim. So imagine we've got the river is going this way, the river water is flowing that way, and we've got Daniel, here he is, and he's swimming across that way. So let's say that Daniel's speed, Daniel can swim 1.8 meters per second. So that's going to be 1.8 to the right and 0 up and down. That's Daniel relative to the river. Plus the river relative to Earth. Well, what's the river doing? The river's going this way and 1.4 meters per second. 0 across 1.4 that way. So the velocity of Daniel is those two vectors added together, 1.8, 1.4. And if I'm now after the speed, then I need to find the magnitude of that. So the square root of 1.8 squared plus 1.4 squared, and that gives me 2.28 meters per second. Okay, how long does it take Daniel to cross the river? Okay, well, there's a couple of ways we can do that, but I'm going to think about here. We've got, speed equals distance over time. And I'm just going to pretend we're in this. Imagine that the water is still. His speed, when the water is still, is 1.8. He's got 50 meters to go. And how much time is that going to take? T. Rearrange this equation. T is 50 over 1.8. And that comes to 27.78 seconds. Now, I'll show you something else about that in a minute, but just let's keep going here first. Next question, describe the position at which he arrives on the opposite bank. Now, you can imagine, here he is, here's Daniel here. He thinks he's swimming this way, but the current's actually pulling him that way. So we're going to think about this triangle that we've got. He is swimming 1.8 meters per second. That way he's getting pulled at 1.4 meters per second that way. I'm just interested in that angle. That angle there is inverse tan of 1.4 over 1.8, and that will give us 37.875 degrees. Okay, so where is he actually ending up? We've got a 50-meter river here, 37.875 there is his angle. Now, if I'm wanting to know where he actually ends up, it's going to end up, up the river here somewhere. I want to find out how far, so let's just find that there. What would I do? Tan of 37.875 is equal to x over 50. X is going to equal 50 tan 37.875, which is 38.89. So he is going to end up 38.89 meters further downstream. Now, just before we finish up, I want to show you something else that we can do. If we are looking at the distance over time. Now, we said that his speed relative to the riverbank was 2.28 meters per second. So if we're thinking about it like that, he's actually swimming this distance here, isn't he? He's not just going 50 meters here, he's actually swimming the hypotenuse of that triangle. Well, that's 38.89. How far is that? What is this distance here? It's the square root of 50 squared plus 38.89 squared, which gives us 63.344 meters. Now, let's just work out how long at this speed, at 2.28 meters per second. So speed equals distance over time. Speed, 2.28, is equal to the distance, 63.34 over time. Rearrange. Time is 63.34 divided by 2.28. 63.34 divided by 2.28, which gives us 27.78 seconds, which is the same as that. See what we did there? Here we used this 1.8 meters per second, and we looked at that 50 meters across the river. Here we did it the other way. We're looking at that there and this speed, and it works as well. Okay, I hope that was helpful. It's probably worth doing this whole quiz again just to make sure you understand it all.